Welcome back, everyone. Good afternoon. Thanks so much for making this a great Streaming Media East 2019. Once again, want to thank all our sponsors. I won't name them one by one again, but really want to thank them and appreciate their input and appreciate all of your input in making the sessions as everything they could be, both to our speakers and our audience, because hopefully you got a chance to ask questions and get involved in conversations rather than just have a sort of sit and get sort of approach to the conference. We're wrapping things up today with a great closing session. Before I say anything else, though, one question for the audience. Thompson twins, or now that's what they call music too? If you get that reference, then you watched Bandersnatch. If you didn't get that reference, you still certainly heard about Bandersnatch, which was the Black Mirror episode that came out at the end of 2018 on Netflix. Choose Your Own Adventure episode. But that wasn't the first interactive forking storyline show that Netflix had released. The company had released 2 children's shows. I believe they were children's shows, right? With Choose Your Own Adventure storylines. And I realize I can't even legally say Choose Your Own Adventure. Well, I can probably say it, but and that was in 2017 already. So it's not entirely new technology, but Bandersnatch was certainly where it hit mainstream and got widespread attention. And as cool as it was to watch, those of us in the industry, especially the really geeky ones who come to shows like this, probably got more excited wondering about how Netflix made it work so seamlessly on every device. And today we're very lucky to be able to hear all about that from Andy Schuler, the manager of video engineering at Netflix. So Andy.
Thank you. Good afternoon. My name is Andy Schuler, and I'm here to describe some of the technology and techniques behind interactive experiences on Netflix. I lead an engineering team focused on source acquisition and encoding technologies, but the work I'm presenting today is a mix. So a lot of it is actually work that was done by stunning colleagues of mine on the UI, player teams, and streaming client technology teams, some of whom even presented slides to this presentation, so a big thank you to all of them. At Netflix, we focus on bringing great stories to life, with emphasis on quality and seamless experiences. To that end, we constantly innovate on new encoding strategies, adaptive streaming algorithms, playback technology, and user experiences. We're very proud of our highly optimized streaming platform, and we're eager to experiment with innovative storytelling techniques as well, building a framework for interactive experiences on existing infrastructure and leveraging our unique scale. The success of these experiments ultimately depends on you, the Netflix member, and your willingness to engage with the story, to accept responsibility of control. This requires a little bit of retraining, given your current binging habits, and as such, each of our interactive titles to date has included a series of tutorials, one for each platform, designed to encourage viewers to pick up their remote control, game controller, or even just their pointer finger and propel the story forward. I particularly enjoyed the tutorial for Bandersnatch, so I thought I'd share that with you guys today. As you watch it, please note the way that the UI interacts with the video. That'll be a topic a little bit later. Let's see if this works.
This is an interactive film where you make choices which alter the story. Throughout your viewing, there will be moments where choices will be presented at the bottom of the screen. Use the left and right buttons on your remote to highlight your selection, then press OK. Keep your remote in hand. Do you understand? Use the left and right buttons on your remote to highlight your selection, then press OK. Once again, you'll need to use your remote to choose yes or no.
Seriously, nobody has a remote control?
Here is your opportunity.
So this is the UI that I mentioned, pops up from the bottom.
Use the left and right buttons
We'll
on
dig
your
into that a
remote
little bit, but
to
that's
highlight your
actually a very
selection,
large part
then
of
press
how
OK.
this all works. Can you guys actually hear it? Okay. Okay.
As an interactive, there will be moments where choices will be presented at the bottom. Highlight your selection.
So, this is a picture of Charlie Brooker. He's the producer of the anthology series Black Mirror and the writer of Bandersnatch. Here he's reviewing an early prototype of the interactive UI. Eric mentioned seamlessness, and that is certainly a theme throughout this presentation. And as engineers, we may focus on one definition of seamlessness, but another really important component to the success of all of these projects has been a tight feedback loop between engineering and creative, which gives a lot of control to storytellers to craft the overall experience for the viewer. In this way, the design and the execution of both the Netflix UI and the media assets delivered by an external production integrate to complete the director's final vision within the product. I'll pause here to review the default path for this presentation, excluding any unforeseen interruptions in our current space-time continuum or nonlinearity bugs. This is what the rest of the presentation should look like with a total TRT of about 20 minutes. So we'll spend a few minutes reviewing the adaptive streaming strategies at play here, talk a little bit about the framework and vocabulary for producing one of these branching narratives, as we call them internally, use Bandersnatch as a case study, and then working backwards, we'll have a look at how these media assets were actually delivered to us, and then how we'd like to utilize SMPTE's IMF for this use case into the future. We may not be the first to experiment with this type of storytelling, but we are the first to do it at this scale. Nearly everything we do at Netflix, we do across the globe in dozens of languages on families of devices installed over the course of 10 years. And I think it's safe to say that everyone in this room is painfully aware of the challenge in deploying a consistent experience across an ecosystem of varying capabilities and implementations. Seamless playback, for example, is a primary objective for the streaming client teams, which is especially tricky in the case of interactive when you don't know what to play ahead of time. Because interactive or not, I think we can all agree that buffering is the enemy. Got Eric back there. Okay, and I know that this is review for most, but I'd like to give a brief primer on adaptive streaming, and specifically some encoding improvements that lead to a seamless streaming experience. A large part of our job on the encoding team is to produce multiple derivatives of the same content so that they can be delivered under a multitude of network conditions. Here are two hypothetical examples of H.264 ABC encodes packaged as ISO BMFF MP4. You can think of these as alternate versions of the same constructed reality. How many of you, show of hands, have actually seen Bandersnatch? Okay, so maybe a few of these jokes will land. Okay, while the data rate of these streams necessarily differ, the structure of each must be consistent, such that all encoded segments align. This allows a player to switch from one stream to another without negatively impacting playback. In this example, an adaptive streaming algorithm may choose to use different segments from each of these streams to match varying network throughput. This is a trivial example of what is an incredibly challenging and complex problem. And until very recently, we guaranteed conformance among different streams by simply restricting segment durations to 2 seconds. So in this graphic, each one of those little boxes represents a 2-second segment. This is not an uncommon practice, as I understand, and as you can see in this graphic, streaming algorithms can switch as needed on a 2-second cadence to adapt to their network throughput. Last year, however, we reevaluated this contract between encoding and playback, instead aligning segment boundaries with shot boundaries, and ultimately optimizing the encoding parameters on a per-shot basis. Now, adaptations during playback are largely hidden by edit decisions inherent into the content itself, and the contract between encoding and streaming also paved the way for arbitrary keyframe insertion, providing very granular control over the structure of an entire encoding ladder within our distributed transcoding workflow. Additionally, quantization is reduced. As you can see, the data rate of our streams can more closely match the actual throughput of a playback session. And where supported, we see up to 50% reduction in the overall size of our encodes for the same quality when compared to our per title encoding optimizations. Okay, let's take a look at the content within these streams. First, a standard title on Netflix, where there is only a default path, is laid out like this, with a simple instruction to the player. Start at frame 0 and play every subsequent frame until you run out, with some exceptions around introduction and credit sequences. As Eric mentioned, Puss in Book was our first official branching narrative title. It launched in May of 2017 and played a lot like a fractured fairy tale. Young members helped Puss navigate his way through a series of conflicts, ultimately helping him escape from an enchanted storybook where he'd been trapped by a despotic narrator. We used Puss as a model to begin working out our acquisition, encoding, and deployment strategy. Here's a graph representing all of the possible paths in Puss. Then in 2018, we launched Minecraft Story Mode, and that pushed the limits of everything that we had built. Then in 2018, then came Bandersnatch. This is a graph generated from the real choice point data for Bandersnatch. The segment descriptions have been removed to prevent spoilers, but each node represents a narrative segment of the story with choices represented as indices. So, a question to the engineers in the room. Having designed a solution for Puss in Book and then asked to support Bandersnatch, what would you do? Luckily, neither of these options were necessary. The branch manager was a tool developed internally to help Black Mirror producers visualize their timelines, evolve the story from script to screen, and ultimately bridge the gap between Charlie Brooker's imagination and our nascent engineering solutions. The tool appears to have been well received. In fact, if you watched Bandersnatch, and if you made the right choices, you may have seen this storyline where Branch Manager makes a cameo. So, let's define interactivity for our context. These are some of the basic rules by which we assume all current branching narratives abide, and some of the vocabulary that we came up with to talk about it. Each title is constructed of a series of interactive segments where each segment contains synchronized media, video, audio, and text. It may contain a choice point prompting the user to make a decision, and also defines what segments to be played after a user has made their selection. Bandersnatch launched in December of last year as a standalone episode of the Black Mirror series. It's about an aspiring game developer in the UK in the 1980s. You help Stefan navigate a series of challenges as he attempts to complete his colossal vision for a new video game, even as Stefan begins to question his own reality. This was the first interactive title marketed to adults, and it was also the culmination of a year's worth of iterative improvements, building on the lessons of previous branching titles, the success of which could now justify additional engineering work to produce a truly seamless experience, with new features including a new UI, decoupling of the download and playback on the client, and adding arbitrary keyframe support in our encoding stack. We'll explore a few of these features in more detail and specifically go behind the scenes of a choice point. One of the most important choices for Stefan is whether to accept or refuse the opportunity to work at this new video game startup, Tuckersoft. On the left, the choice point is represented as a graph similar to that in Branch Manager. And on the right is the Netflix UI. The choice point appears at the end of an interactive segment that we've labeled job_offer for the purposes of this example, and the segment defines two possible subsequent segments, accept and refuse. A series of UI states define the member experience at each choice point. The phases of a choice point are initialization, selection, timeout, and hide. Let's go back through those one more time. Initialization, choice selection. This is when you're actually able to interact with the UI, and you can see that your countdown has started. After your countdown is over, your choice is locked in, and the UI fades away. Thanks to the tight collaboration that I mentioned earlier, the production was actually able to plan around the UI, all the elements, and to make sure that they set up each shot in a way that it would integrate seamlessly. We can map these UI states onto the playback timeline itself. And in the top right corner, you can see a snippet of the code defining the beginning and the end of each phase. These values are unique to a choice point, so creatives have ultimate control over the pacing of each choice point. One choice may feel rather leisurely, like in the tutorial, while I can say that others in Bandersnatch are far more frantic. Zooming out, we can start to see what the layout of our media files really look like. The default path is also used to construct the layout of the media files themselves. It's only when a user deviates from the default choice that she seamlessly jumps to another point in the timeline. Otherwise, the player can just keep playing, downloading and appending bytes like normal. Let's say that you, like most, chose the most empathetic option for Stefan, and he accepts the job. Because the accept branch is also the default, the player simply rolls into the next segment, no problem. But there's a 50% chance you'll select the refuse branch. And as you can see, the refuse branch is located somewhere in the middle of the sequence. In order to seamlessly transition to one of two equally probable outcomes, we simply cache both, effectively doubling the video rate and the memory on the device. Thank PAX for those super efficient shot-based encodes. Once the choice is locked, media samples from the appropriate segment are appended to the media source buffer, and the cache can be purged. This is how the player teams decoupled downloading logic from playback logic and content timestamps from playback timestamps, and provide a seamless transition from one segment to another. Okay, if I'm going to be the one to talk about IMF, so be it. Working our way backwards, let's look at the files that are delivered to us as mezzanines, and I'll explain my chicken versus zombie analogy. Before Bandersnatch was Minecraft story mode, and very early in that series, you're given a hypothetical option. Would you rather face 100 chicken-sized zombies or 10 zombie-sized chickens? Did I say that right? 10 zombie-sized chickens. Personally, I chose the chicken-sized zombies just because it seems more scalable. I don't know if any of you caught the OTT microservices panel, but they kind of touched on this as well. We'll get back to that. As I mentioned a few minutes ago, until Bandersnatch, our contract with the adaptive streaming engine deployed onto clients was based on 2-second segments. This essentially defined our encoding GOPs and all of our video encoding recipes for almost the entire past 10 years. It was difficult to justify a large amount of engineering work before we'd even demonstrated any kind of success around interactive. So, our initial source delivery model for Puss, Minecraft, and others pushed the complexity of our encoding pipeline upstream to our fulfillment partners, who would receive all of the media for each interactive segment from the production and prepare it for delivery to Netflix according to a custom spec. Our initial spec required each interactive segment to begin on a 2-second boundary, ensuring that the first frame of each interactive segment was a keyframe after running it through our encoding pipeline. A keyframe is required for the player to randomly access any particular segment. Laying out these media files was manual, tedious work, and obviously error-prone. you can see that it also introduces a significant amount of overhead in the form of black frames and silent audio samples. Additionally, since clients need to know where each segment begins and ends, which choices default, and more, we also defined a simple XML scheme, which was produced and delivered by those same fulfillment partners. The choice map XML annotates the timeline for easy traversal. After ingesting the aligned sources, that's video, multiple languages of audio, multiple languages of text, and the choice map, our timeline looks something like this, where the random access points defined by the XML are represented by these little diamonds. There were multiple disadvantages to this model. For example, even minor changes to the source media required a full redelivery almost every time, including resyncing the XML to match all the new media timelines. The epitome of this giant chicken model, as I will refer to it, was episode 4 of Minecraft Story Mode, A Rock in a Hard Place. For this one episode, we received aligned audio, video, and text assets, each with a duration of nearly 20 hours, which beat our previous non-branching record holder, Slow TV, the Telemark Canal, which despite its name is riveting, currently live in the US and over 11 hours long. Luckily, our chunked encoding system doesn't get too hung up on large files, though there were some challenges. Ultimately, we were successful in that we proved our users think this interactive thing is pretty cool, and ultimately decided that we needed a more scalable model. Since componentized media delivery is a primary advantage for IMF users, like Netflix, it seems like a natural fit for this type of application. Prior to Bandersnatch, and following some of those new encoding features that we talked about, we updated our source spec to use the IMF marker track to annotate the timeline in band within the CPL and eliminate the need for a separate choice map altogether. By utilizing the bundled marker track and a big engineering investment to add the ability to set arbitrary keyframes within our encoding stack, we were able to reduce the overhead and a lot of complexity from our mastering and delivery specs. This was how we ingested Bandersnatch and is our current delivery model. In this graphic, the tiny diamonds above the timeline indicate where keyframes will be placed in encodes for random access by the player. So, what's next? In a word, scalability. As I've outlined here, we're focused on building a framework for developing new storytelling techniques and a platform for delivering a high-quality, seamless experience. Many of the processes we employed will need to be streamlined and potentially standardized to make these workflows ubiquitous. Personally, I'd like to continue to lean on IMF primitives to enable componentized delivery in whatever way makes the most sense for production and post-production teams, allowing us to further decouple upstream and downstream systems. We're currently evaluating options around segment-based delivery, for example, potentially enabling additional optimizations and flexibility into the future. But in the meantime, please check out some of the interactive titles on Netflix. There are more than those that I'd mentioned here. And ping me, Schuler at netflix.com, if you'd like to be a part of what happens next. Thank you.
Thank you so much, Andy, and our apologies for the audio problem. We're not sure why that happened. Any questions from the audience?
Really?
Hi there.
Oh, sorry, we got.
Hi. So it looks like an incredible engineering feat, and it also looks like an expensive production feat. So how do you justify the combination of both the, like I said, amazing engineering approach, but with the ability to have to create all this content that may or may not be consumed?
So in my experience, Netflix makes big bets. We try to find the best engineering trade-offs for those bets, but more and more content is sort of driving a lot of these decisions. So, and I don't mean content as a team, I mean content as a product. So if there's a piece of IP that is really exciting and we want to go after, we just kind of figure out how to make it happen. So so one thing that I tried to sort of drive home in this presentation is that it really wasn't until we proved out the success and had numbers that showed that people were engaging with the content that we went ahead and we did that additional engineering effort to really polish the experience and make it everything that Bandersnatch was.
Other question? Yes, up here.
So I mostly work on the creative side of things, but I know a lot on the technical side, and I've spent a lot of my career listening to engineers tell me why we can't do something before we finally circle around to how we can make it happen. So whenever you were approached with either this or previous opportunities, was there an immediate yes from your team, or how was the collaboration there in working through how to make this work?
So I mentioned early on that a lot of the really heavy lifting was done on UI and player teams, streaming client teams. And actually, if there's one thing to take away from my presentation, it's that we, on the encoding side, pushed as much of the work out of our team as possible initially. But in the meantime, we were already working on a lot of the features that ended up paying off really big for interactive. So, I mean, one great thing about Netflix is that you're encouraged to push back when you're being asked to do something that you think is incorrect or inefficient. But generally, when we see a big bet like this, we try to make a strategic investment that says, you know, we're willing to put so much time on the line, we're willing to move things around on our roadmap to prove that this is either successful or unsuccessful so that we can, you know, move on to the next experiment. So, no, I don't think that we didn't push back really hard on this as a concept. Mostly we just tried to think about how we could enable what the UI and player teams needed for us, since we're on the back end and in a lot of cases front-loaded with that kind of development work. So it's a good question. Hey.
Netflix is known for changing the game. Is there anything, any sneak peeks that you could give us since you're here today that we could look forward to?
I wish. I actually, right up to the... right up to the moment, no, and we'll cut off the live stream. Right up to the moment I was coming up here, I was checking my email to see if anything had dropped or launched or anything like that. I can tell you that in my experience, when Netflix sees successes like this, when they make a big bet and it's successful, they double down. So I would expect to see more. But what or when, I can't tell.
All right, June, you've got a question.
So I watched Bandersnatch over and over again one night. I also noticed the Man vs. Wild guy has an interactive series actually now. Did that come before or after Bandersnatch?
That launched just recently, You vs. Wild.
And was that the same kind of underlying architecture as well?
It's a great question. Actually, it delivered earlier. So I think that it came in with that initial delivery spec. Which means that there's a chance that in certain scenarios, you know, you might catch a black frame here or there based on the way that we lay out those media files. But the player teams did an amazing job of, you know, hiding all of our, I hate to call it sloppiness, but you know, our solution, our initial engineering solution. But yeah, You vs. Wild, I launched just recently, I believe, within the last couple months.
Any other questions? All right.
I can turn the microphone on. So certain platforms weren't supported, were they? Was there a decision that were they simply dead ends, or was there a decision to release at that stage and deal with the other platforms that weren't supported further on?
Yeah, I mean, there's a very strong preference at Netflix to deploy onto as many platforms as possible to have a very consistent experience. But in some cases, I guess the engineering work maybe just is too large or whatever to hit a particular deadline. I can't speak to the specifics of any player implementation because I'm a back-end guy, but I know that we try really hard to deploy onto as many platforms as possible, and even there were experiments to try to get into platforms, older versions of clients that we knew it was a little dicey as to whether they could support this or not, but we did do a lot of engineering to try to make that happen, and we're successful in most cases.
All right, well, once again, thank you very much, Andy.
Yep, thank you.
And thank you, everyone. Hopefully, we'll see a lot of you at Streaming Media West in Los Angeles in November, and then again at Streaming Media East a year from now. Thanks again.